Hello everyone. Now we're going to keep doing some right triangle trig. Still got the Mason floating head going on. So these are problems that you need to be able to do. They're very similar to the other ones that we just did. In fact, once we get the pictures, you're going to see that there's basically one like everything that we've done. You need to be able to do these to do your escape room. And your escape room is going to be a series of trig questions. So these are just basically practice problems for you. This says you're looking out the window of your apartment and a skyscraper. So we'll say like our apartment's going to be shorter and our skyscraper is going to be taller. Okay. So there's our two buildings and we are just some person in this window and it says from your vantage point there is an angle of elevation of 65 degrees to the top. So angle of elevation, remember you always have to draw horizontal and you draw up. Angle of elevation, this is 65 degrees. And then it says angle of depression of 15 degrees. So this is 15 degrees. Getting the picture is definitely going to be the hard part. Now, the distance between the buildings is 100 feet, so we know this distance. And what we need to do is try and figure out the height of the building. So let's do what we did before, h1, h2. I know that if I add those together, I'll get the height of the skyscraper. So to find those, I'm going to write two tangent statements because it's opposite adjacent. We'll say the tangent of 65 is h1 over 100, and the tangent of 15 is h2 over 100. So to solve these equations, you multiply both sides by 100. 100 times the tangent of 65 is h1. 100 times the tangent of 15 is h2. And now we just need to add them together. So we'll use our calculator, because this is definitely calculator work. Come here. 100 tangent 65 plus 100 tangent 15. 100 tangent 65 plus 100 tangent 15. I get 241.25. So the tower is 241.25 feet tall. That's them added together. If I had to ask, like, what's the height of the window, I would just do h2, so 100 tangent 15. And if you wanted to figure out how high the skyscraper is above you, that's h1, you could get that. But all I really care about is that guy. 241 is the height of the tower. All right, another one. Let's see. We got from the top of a 100-foot building, a man observes a car. This seems like the mountain problem. Yeah, okay. So we've got our tower. And this guy's looking down, so this one's a little bit different. Okay, so there's a guy up here. We'll just put some dude up here. Hey, what's up? He's looking out. That's his, no. He's looking out. And it says angle depression changes from 18 to 35. So I think I want to maybe draw like the base of this. I'm going to have to build this out. We got a car down here. He's looking at a car. So here's my car. This is going to be lovely. Oh, yeah, boom. Yeah, great. Okay. He's got a car and he looks at it and then he looks at it again. And he's got two angles of depression. So remember, that's not these angles, that's these angles, which will also be angles of elevation. So let's see. It says he looks out and it changes from 18 to 35. So it's 18 degrees when he's out farther, and then it gets closer, and now it's 35 degrees. So what you need to realize is we have parallel lines. Parallel lines right here, and I don't think that one is actually horizontal. Why is that not horizontal? Fix that. These are parallel lines. Is that still what? There. Okay. It's happening. This is a parallel line. These are called transversals. So they're passing between two parallel lines. Those are alternate interior angles. You have alternate interior angles. This is 18 degrees, and this is 35 degrees. That's the thing you need to recognize is that we have alternate interior angles. Another way of thinking about this is if you're looking out from the top and you look down, I think it makes sense that if somebody is on the ground looking out, they look up, they have to look up at the same angle that you have to look down. So when you look at the angle of depression, that's also the angle of elevation for whatever's on the ground. Now what we're trying to figure out is how far did the car travel. So like from here to there, that'd be like our x. And I have a feeling I'm going to need another variable here, so let's just call that guy y. Because I'm going to need those two distances. Do I know anything? I know it's a 100-foot building. Is that it? Okay. So let's write some tangent statements, see if we can build ourselves a little system. The tangent of 18 is opposite 100 over adjacent. So that's x plus y. Similarly, the tangent of 35 is 100 over y. The tangent of 35, opposite, adjacent. So what can we do here? We need to find x plus y. Can we do that? X plus y. Yeah, we can do that. We can find x plus y really easily. This is a proportion, so you might remember that you can flip these things. This is the same as saying x plus y is 100 over the tangent of 18. To solve, when the variable's in the denominator, you have to divide. So I can figure out what x plus y is pretty easily by doing 100 divided by the tangent of 18, and that is 307.77. So x plus y is 307.77 feet. We know how far the car was at the beginning, which means now I can figure out x, right? Because if I know it's x plus y, and I can plug this in, or maybe I can figure out y. I think I can figure out y. Yeah, I can figure out y. If I know these two, I can figure out y. Because, let's see, tangent of 35 is 100 over y. So I can just say, I mean, I could have done that in the beginning, I guess. Just multiply both sides by y and divide. You get y is 100 divided by the tangent of 35. I didn't even need to do that to get y. So y is 100 divided by tangent 35. That's the easy part. 100 divided by tangent 35 is 142.81. So if I want to figure out x, I know the total distance from the car originally to the building, and now I know this distance. If I want to figure out how far the car traveled, I just need to subtract 307 minus 142. So 307, again, look how I'm not rounding anything, minus 142, 164.95. So that means this is 164.95 feet. That's how far the car traveled. So the car traveled, it's a word problem, so we should put a word answer in here. The car traveled 164.95 feet. Oh, whoa, that's not how you spell feet. There you go. Boom. All right, so that one's actually easier than the mountain problem. Do one more. Flying above the Ohio River at an altitude of 3,500 feet. So let's see. Oh, we got maybe two more, I think. Plane. We're going to do a front view of the plane. So it's coming at us like that. You got a little tail fin in the back. Cool. And you're flying over the Ohio River. So we got an altitude here. And we can look out the right window and we can look out the left window. Okay, so I think technically this would be the right window if it's coming at us. Doesn't really make a difference though. You look out the right window and you can see an angle of depression of 79 degrees. So you put 79 degrees here and now you're done. You missed it. You got it wrong. If you label that as 79 degrees, you're going to get the whole problem wrong because your picture is wrong. Remember, from the horizontal, if you look out the window and you look down, that is 79 degrees. This is 79 degrees, which means this is 79 degrees. Other side, 68 degrees, which means this is 68 degrees. What else do we know? Altitude is 3,500 feet. Planes have altimeters. They can tell you how high up they are. Okay? What are we trying to find? How wide is the river? Okay. We'll call this like distance 1, distance 2. You can't see that. My head's in the way. My floating head's in the way. Okay. We know, I think we got everything we needed labeled now. We just need to now piece this together. We know we need to add these two distances because this is the river. You know, like that's the width of the river. So to find that, we're going to have to find two statements, which I think we can do. Let's see. Opposite over adjacent again. Tangent of 79 is 3,500 over the first distance. And tangent of 68 is 3,500 over the second distance. Which means, multiply both sides by d1. You get d1. Well, we could just do this in one step. Is 3,500 divided by the tangent of 79. And d2 is 3,500 divided by the tangent of 68. So we just got to find these two things, and then add them together. And that's cool. So I'll find these two distances, and I'll be able to add them together. I need a calculator, though. So, there you go. 3,500 divided by the tangent of 79. There's the first distance, 3,500 divided by the tangent of 68. And there's the second distance. And if I want to find the width of the river, I need to add those together. So 680 plus 1414, 2094.42. 2094.42. So the width of the Ohio River is 2094.42 feet. Is that right? Is it actually that wide? Let me see. Well, let's do a little Google here. How wide is the Ohio River? Well, I guess it depends because it's a really long river. But downtown, it says it's about half a mile. Half a mile would be, what, 2,600 feet? So 20, yeah, that seems reasonable. Okay, seems reasonable. But it's definitely going to vary. So 2,000 feet from where we are. Cool. One more? Yeah, that's the last one. All right, so this is another WLW tower question. So I'm looking out the window of my Z3 classroom, which, I mean, I actually did this. It's over there. I just got to look at that window. And I got my tower, which I drew so lovely before. In fact, I'm just going to steal it from before. Where is that? Where's my WLW tower? Aha, check it out. Yeah. Oh, we take this guy. Copy. Yep. Okay. Paste. Sick. Got my WLW tower. Awesome. So I'm looking out the window and realize I'm on the 3rd floor. So if I'm on the 3rd floor, I'm not on the ground. I'm looking out the window, which we'll just say is right here. All right. Now I got a distance to the tower, and I'm going to look up at the top, and I'm going to look down at the bottom. And it says, I've looked up, the tower is 750 feet tall. And I know that the angle of depression to the bottom, so angle of depression is from the horizontal looking down, that's only 1 degree. And I use my phone. You got that compass thing on your phone, the little protractor. And then this will say is 9 degrees. Because that's angle of elevation. So what now can we do here? Let's write a couple statements. Maybe this will get kind of the wheels turning. Tangent of, we're trying to find how far are we this distance. So tangent of 9 degrees is, I don't know this height. Let's say H2 and H1. H2 over the distance. And tangent of 1 degree is H1 over the distance. So this is going to be one where we're going to have to create a little system again. But I do know H1 plus H2. So when I get H1 plus H2 is 750, I'll be able to build an equation pretty easily. I'm basically starting with this idea. I know that they add up to 750. And now I know something about H2 and H1. I don't know why I wrote them in that order. Maybe it's because it's top to bottom. But H1, if you multiply both sides by D, you get D times tangent of 1 plus, same thing here, D times tangent of 9. And those add to 750. And this is where, again, you just have to realize these are numbers. The tangent of 1 and the tangent of 9 are just horrible decimals. So when I want to figure out what their like terms are, or when I want to figure out what that decimal is, I'm just going to add them. They're like terms. Tangent of 1 plus tangent of 9. 0.175 or 176. 0.176 times the distance is 750. I'm just writing that to kind of help you see the last step to solve for this. Since you're multiplying by D, you would divide. 750 divided by that. So I'll do 750 divided by that 1.6 decimal. 750 divided by this guy. And I get 4265.25. 4265.25 feet. So we're about 4,200 feet from the WLW tower. All right. If you can do those problems, you can do the escape room. So what you're going to do is, with your table, you're going to try and go through all of the questions in the escape room. And once you get done, you're done. So good luck, and like and subscribe.